Okay, individual demand curve, price consumption curve. Curve tracing the utility maximizing combinations of two goods, optimal consumptions of two goods, as the price of one changes. Price of food decrease and decrease in earlier example, right? And individual demand curve. This relating the quantity of goods or demand for food that a single consumer will purchase to its price. Relationship between price and demand for that good. Okay? The individual demand curve has two important properties. Number one, the level of utility that can be attained changes as we move along the curve. Right? The level of utility that can be attained changes as we move along the curve. Okay? Price changes. Then consumers' purchasing power changes. So different purchasing power leading to different utility level. Think about price consumption curve, right? Price consumption curve. At point A, utility level is U1. At point B, utility level is U2, greater than U1. And at point D, utility level is U3, higher than utility level of U2, right? So level of utility changes as we move along the demand curve, right? Number two, at every point on the demand curve, the consumer is maximizing utility by the satisfying condition that marginal rate of substitution of food for clothing equals the ratio of price of food and clothing. In other words, these earlier 3 points, right? 3 points should be optimal consumption bundles of two goods. Solution of utility maximization problem. Okay? The condition for utility maximization solution is MRS, slope of each indifference curve, is equal to slope of budget constraint, respective. So that is PC over PF, right? 3 points satisfying this first order condition of utility maximization condition. Next slide. So income changes. So first we studied price of one good changes. Second case is what happens when income changes, right? So figure 4.2, effects of income changes. An increase in income, then what happens? Income increase, then budget constraint shift to the right, but slope of budget constraint same, PC over PF is every time same, right? With the price of all goods fixed causes consumers to alter their choice of market baskets. In part A, the baskets that maximize consumer satisfaction for various income. Originally, budget constraint here and consumers solve utility maximization solution to find optimal consumption bundles of two goods. That happened at point A. And individual consumers' utility level should be U1. Okay? Now, this individual's income increase, then budget constraint shift to the right, like that. But slope of budget constraint same, because only income changes. Price of food and price of clothing same. So slope same. Anyway, at this new budget constraint, consumers have to solve utility maximization problem again. And solution happen at point B, where MRS of U2 is equal to slope of new budget constraint, PC over PF. That happened at point B, isn't it? Right? And now your income increase again, for example, like this. Then what happened? Anyway, consumers solve utility maximization problem again because budget constraint is now changes, right, from here to here. and solve utility maximization problem again and to find new consumption bundles of food and clothing. That happen. That is point D. So income increase, and this graph, consumption of food increase 4 to 10, 10 to 16. At the same time, consumption of clothing increase 3 to 5, 5 to 7. Okay? That is impacts of income changes. The shift to the right of demand curve in response to the increase in income is shown in part B. Part B is Y variable is price, X variable food consumption, same to earlier graph. I'm sorry, this one is new. Price of food, price of demand for food. In this example, price of food decreases $2 to $1 and $0.50. But here, price, no change. So, price of food every time, $1. But income increase, right? Then this one and this one and this one. Point E is one-to-one relationship with point A. G is related with point B. Point H is related to one-to-one relationship with point D. But Y variable is food, so horizontal demand curve. Right? That is explained here. So we said this is an income consumption curve. Curve tracing the utility maximizing combinations of two goods, demand for two goods, food and clothing, as consumers' income increase, budget constraints expand to the right, and finding new optimal consumption bundles of two goods. That is income consumption curve. In earlier example, here, price consumption curve, because price of food decreased $2 to $1 to $0.50 like this. Price consumption curve. But XY variable same, right? Here, same XY variable same, but income changes, so budget constraint shift to the right like this, and we can trace income consumption curve like this, right? Now, normal versus inferior good. Normal versus inferior good. What is inferior good? An increase in a person's income can lead to less consumption of one of the two goods being purchased. Then we said inferior good. Here, X variable is hamburger, Y variable is steak, demand for consumption of steak, right? Your income increased, then what happened? Your income increased, then budget constraint, right? Shift above like this, and consumer solve utility maximization solution again. Originally, A is optimal consumption bundles when your income is this one, right? Your income increase, you moving B, A to B. Then what happened? Consumption of hamburger increase, consumption of steak also increase, right? So when you're moving A to B, hamburger and steak is normal good because income increase, budget constraint expands, then demand for two goods increase. So two goods are normal good. Now think about when your income increase again, then you face new budget constraint like this. And solution of utility maximization solution facing this budget constraint occurred at point C. At point C, what happened compared to point B? Consumption of hamburger decreased here to here, right? Consumption of hamburger decreased. Income increased, then demand for that good decreased. That is definition of inferior good, isn't it? So when we're moving B to C, hamburger is inferior good. Can you understand? Also, sometimes then steak is inferior good or normal good when you're moving B to C. When we moving B to C, your income increase from this one to this one. Consumption of steak increase when you moving B to C, right? So steak is normal good. Income increase, steak increase. So steak is normal good. But when you moving B to C, Hamburg is inferior good. So should be careful for this. So usually you have to solve this kind of some O-stripe question based on this kind of thing. Steak is inferior good or normal good. Hamburg is inferior good or normal good. Okay? Next slide. Now think about angle good. Angle good. Angle curves, I'm sorry. Angle curves, right? So angle curve is, so X variable is demand for food, consumption of food. Y variable is income, right? Income. So how this kind of angle curve is derived? Now think about this, right? Income consumption curve. Your income increase, consumption bundles of two goods changes, moving A, B, D. And here we draw price of food. Y variable is price of food and X variable is food. Demand for food is need. Right? Then, like this, price no change, demand for food increase when your income increase or your budget constraint expands to the right. Angle curve is just same to this one, right? But here, Y variable is your income rather than price. So when at point A, your income is $10, for example, so your demand for food is 4. So this point. At point B, your income increased, for example, to $20. The income increased to $20, right? Then demand for food, $10. At point D, your demand increased to $40. So your income increased to $40 and demand also increased. So positive curve like this. That is just this one is income and food. Demand for food, right? So this point is equivalent to panel A of earlier graph at A, I think. And this point is one-to-one relationship with point B of earlier graph. And this is a point, income consumption curve of point C or D, one-to-one relationship with point D of income consumption curve of earlier graph, isn't it? So that is angle curve. Okay? Now in A, food is, now angle curve is like this, right? So here food is normal good. Why? Income increase, then demand for food or consumption of food increase. So normal good by definition. But now think about panel B. So angle curve shaped like this. Income increase $10 to $20, then demand for hamburger increase like this. So when you're moving, income increase $10 to $20, hamburger is normal good. Income increase, hamburger increase, so normal good. But your income increase again, $20 to $30, then what happened? Your demand for hamburger decrease instead of increase, right? So when we moving here to here, $20 to $30, demand for hamburger decrease. Negative relationship is income and consumption of hamburger. So inferior at this case. Okay? And the inferior good for income greater than $20 per month. Angle curve relating the consumption of a good to income, demand for good to income. That is angle curve. Got it? Okay, example 4.1. Consumers' expenditures in the United States. We can derive angle curves for groups of consumers. This information is particularly useful if we want to see how consumer spending changes among different income groups, right? That is expenditures or demand for entertainment by low-income individual, right? Or this is demand for owned dwelling service by low-income, right? Low-income household. Or this is a demand for health care by this income household, or demand for food, demand for clothing, like this, right? Similarly, this one is demand for entertainment by really rich people in the United States. That is demand for clothing by rich income owner. That is demand for food by this group. This is a demand for health care by this group. Can you understand how to interpret, see this kind of table, right? So from here we know that income increase and increase. First, think about entertainment. Household income increase and increase and increase. This one is X variable, for example, right? Then what happens in demand, optimal consumption of entertainment? Increase, increase, and increase, right? So positive. And we know that your income increase and increase, increasing consumption of entertainment also increase greatly at this, for example, here to here, right? Consumption of entertainment increase, jump positively. How about owned dwelling? Income increase, then demand for owned dwelling increase until owned dwelling, right? So purchasing apartment, for example, increase and increase greatly. Also at this range, increase greatly. So positive relations, angle curve is positive, right? How about rented dwelling? Rented dwelling. Your income increase, rented dwelling decrease. Increase, decrease. Increase, decrease, decrease, like this. You become richer and richer. Demand for renting apartments decrease, usually, right? That is rented dwelling. How about healthcare? Your income increase, demand for healthcare increase greatly with increasing rate, like this. How about demand for food? Increase, 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 and increase anyway. Clothing, increase, increase, and increase. So graphically, this one is like this. What is this? What is this? This is a demand for healthcare. X variable is income, that is consumption of healthcare service. What happened? Income increase, demand for healthcare increase. But after this, what happened? Income increase, demand for healthcare increase greatly, isn't it? How about this? This is a demand for a rented dwelling, showing same pattern. Your income increase and increase. Demand for dwellings, owning dwellings, purchasing apartment or houses increase greatly. What is this? This is a demand for rented dwelling. This is a demand for entertainment. You become richer and richer, your consumption of entertainment and healthcare service increase greatly. This is a rented dwelling, right? Decrease, increase, decrease, and decrease, and increase. Now think about this. Here, yeah, right? Rented dwelling, income increase, decrease, increase, decrease, increase, decrease, like this. That is this one. Angle curve of annual expenditure and annual income. Income increase, demand for each service, like this. Average per household expenditures on rented dwelling, healthcare, and entertainment are plotted as fluctuations, functions of annual income. Healthcare and entertainment are normal good. As expenditure increase, your income increase. Consumption increase with your income. Rental housing, however, is an inferior good for income above $40,000. Your income is $40,000. That is negative. Okay. So next section is individual demand. So as I said before, so substitutes and complements of individual demand. So what is substitutes? Two goods are substitutes if an increase in the price of one good leads to an increase in the other quantity demand for others. That is substitutes, right? Price of latte increase, then demand for latte decrease. At the same time, demand for Americano increase, right? So we said substitutes. And complements. Two goods are complements. If increasing the price of one good is to decrease the quantity demanded of the other, right? Demand for price of latte increase, then demand for latte, consumption of latte decrease. At the same time, consumption of coffee burn decrease, right? So coffee burns and latte is a complement, isn't it? Two goods are independent. If a change in the price of one good has no effect on quantity demand of the other. The fact that goods can be complements or substitutes suggests that when studying the effect of price change in one market, it may be important to look at the consequences in related market. Okay, we go next slide. Section 2, income and substitution effects. A fall in the price of goods has two effects. Consumers will tend to purchase more of the good that has become cheaper and less of those goods that are now relatively more expensive. Right? This response to change in relative price of goods is called the substitution effect. Number 2, because one of the goods is now cheaper, consumers enjoy an increase in real purchasing power or real income. So with given income, you can purchase more, simply talking. The change in demand resulting from this change in real purchasing power is called the income effect. Okay? So effects. There are two effects, substitution effect and income effect. Okay? So substitution effect, changing in consumption of a good associated with a change in its price with level of utility held constant. That is definition. Change in income consumption of a good related with a change in its price with under the assumption that the level of utility held constant. In other words, utility level constant. Income effect. Change in consumption of good resulting from an increase in purchasing power with relative price held constant. In figure 4.6, the total effect of change in price is given theoretically by the sum of substitution effect and income effect. Total effect is substitution effect plus income effect. Originally, right, that is budget constraint. At this budget constraint, consumers solve utility maximization solutions. Optimization happens at point A, right? So optimal consumption of food is F1, optimal consumption of clothing is C1. Now, price decrease. So budget constraint rotates to the right like this. Why that happen? Because price of food decrease. For example, $1 to $0.50, right? Then what happens? Consumers have to solve utility maximization problem again because budget constraint changes, right? So based on this new budget constraint, you solve utility maximization problem again. Then optimal solution occurred at point B, where consumption of food is F2, optimal consumption of clothing is C2. So total effect is movement A to B. Okay? This total effect composed of two things, substitution effect and income effect. Substitution effect means, what is definition of substitution effect? Change in consumption of a good related with a change in its price, with the level of utility under the assumption that the level of utility held constant. Right? Only substitution effect said change in consumption because of change in price only. Holding utility level constant. Utility level is U1. Okay? That is substitution effect. Okay, now think about this. Original price line is this one. Budget line is like this. Now change like this. Right? So total effect is A to B. or good one case F1 to F2. Substitution effect said, definition of substitution effect is demand change in consumption of food and clothing only due to change in relative price, holding utility level constant. Okay? So, relative price is slope of budget constraint. Slope of budget constraint decrease from here to here. Right? And utility level constant at U1. Then you can draw new budget constraint tangent at original utility curve U1. Then you can find point D. Right? So think about movement A to D. What is A to D? Only relative price changes from here to here and tangenting holding same utility level. Okay? So F1 to E is substitution effect. And income effect, movement D to B, simply talking. What is income effect? Income effect is change in consumption of two goods, demand for two goods, consumption bundles of two goods, only due to change in income, change in purchasing power from here to here, holding relative price constant. Okay? So D to B is income effect. So actually you already studied this kind of thing in chapter 21 of main course Introduction to Economics. Right? So total effect, for example, for demand for food case, total effect is A to B. This is consists of substitution effect F1E plus income effect E to F. Okay? I'd like to explain this again. Right? F, clothing. Anyway, consumers solve utility maximization problem. Right? Food, clothing. Subject to budget. That is C is equal to PF, PC, what I'm talking. Income minus PF over PCF. Right? Now, originally this one was here. Right? And your choice is, for example, that is U1, utility consumption is here. Now, price of food decrease. Then, budget constraint rotates like this. I'm sorry, add one. Like this. That is new budget constraint. Right? New budget constraint. Then you solve utility maximization solution again based on new budget constraint. Solve this problem again with different budget constraint, this one. Right? Then find this kind of thing. Look at this kind of thing. Utility level is, for example, U2, like this. Right? That is point B, point A. Right? And so total change should be here to here. This one can be composed of substitution and income effect. How to draw substitution effect? Right? You draw. That is new budget constraint. Right? So you draw new budget constraint, imaginary budget constraint, slope equaling to new one. Then like this. Right? Then you can find the tangent point. That is point D. Okay? So movement A to D, think about. That is substitution effect. Anyway, utility level same, but only relative price changes from here to here, here to here, right? So that is substitution effect, right? Now think about move on to D to B. What happened? This budget constraint and this budget constraint, new budget constraint, and imaginary budget constraint parallel with each other. In other words, PF over PC, same slope, right? But you can touch higher utility curve, higher, right? Higher purchasing more, movement to B to C. That is income effect. That is substitution effect, and that is income effect. Okay? So you have to practice for yourself. So graphing correctly, right? A decrease in the price of food has both an income effect and substitution effect. The consumer is initially at point A on budget line RS, right? RS, this one, RS. When the price of food falls, consumption increase by F1, F2, right? New solution occurred at point B. So F1 to F2, that is total effect, right? The substitution effect F1E associated with a move A to D changes the relative price of food and clothing, but keeps real income or utility level constant, right? Utility level, only price changes from here to here, but you can touch same indifference curve, holding utility level constant. So movement F1 to E is substitution effect. And income effect, EF2, associated with a move from D to B, keeps relative price constant. So parallel to indifference curve, budget constraint, parallel with each other, right? Because same relative price, P1 over P2, PF over PC, right? Keeps relative price constant, but increase purchasing power. Budget constraint, movement from here to here, here to here, right? Purchasing power or income increase from here to here. So movement of D to B or EF2 is income effect. Okay? Food is a normal good because the income effect is positive. Here to here, income effect is positive, right? So food is normal good. Okay, I'd like to summarize using some like this. Now here, now anyway here, price of food decrease, right? So in this graph, price of food decrease. This one calls two things, right? First one is substitution effect. The other is income effect, right? There are two effects. Substitution effect. What's substitution effect? When price of food decrease, then slope of budget constraint, that is relative price, PF over PC, decrease. Price of clothing, same, but price of food decrease. So slope of budget constraint decrease, right? Under the condition that utility level, satisfaction level constant. That is definition of substitution effect, isn't it? Right? Then what is income effect? Purchasing power, or simply income, or purchasing power increase, right? Holding PF over PC constant. That is income effect, isn't it? Right? Then what happened in this graph? Relative price, that is relative price of food decrease. Price of food decrease relatively. Then demand for food increase. Think about a negative relationship of price and consumption or demand, right? So this one has two things effect on then food consumption decrease, right? I'm sorry, food consumption or demand for food increase, right? When this happens, price of food relatively decrease, then demand for food increase. Substitution effect, positive, right? So substitution effect for food positive. And what happened in clothing consumption? Increase or decrease? Relative price of food decrease. This directly means relative price clothing increase, right? Relative price of increasing is reciprocal value of this PC over PF. Price of clothing increase. Then demand for clothing decrease. So negative impact. Price changes. This cause affect positively on food consumption, effect negatively on demand for clothing. Right? That is substitution effect. You moving A to D. Consumption of food increase, consumption of clothing decrease. C1 to C2. Right? That is substitution effect. Now, income effect, what happened? Purchasing power increase. Then, demand for consumption of food increase or decrease. When you're moving D to B, income increase, purchasing power increase. Then consumption of food increase, right? Consumption of food increase. Can you understand? Right? And then what happened in consumption of clothing? When you move in D to B, consumption of clothing also increase. Right? Moving here to here. Anyway, this one is also increase. So, positive. Right? Anyway, we know that price of food decrease in utility maximization problem. U C1, U F, clothing, so budget constraint is C is equal to I over PC minus PF over PC F. Right? Here, PF decrease. So relative price, budget constraint rotate to the right like this. Then the effect on, just focus on effect on good one, effect on food. Right? Substitution effect positive. PF, relative price of PF decrease, demand for food increase. Right? And income effect. Anyway, purchasing power increase because price of one good decrease. So it is like increasing your income. You can purchase more than before because price of one good decrease, right? So you become richer, in other words. So consumption of food increase, right? So total impact is positive substitution effect plus positive income effect, right? If this is positive, we said normal good. Normal good. Okay, we just focus on X variable, right? That is explanation of this slide. Okay? So, at this figure only, this slide only explain impact on food, right? So, increase in F means in substitution effect, movement F1 to E, F1E, right? Income effect is E2, EF2. That is positive, EF2 is positive, right? So that is summary of this graph. Can you understand? Right? Anyway, we know the price of food decrease, right? Demand for food increase. Positive substitution effect, positive income effect. So total effect is positive, so demand for food increase. Price decrease, demand for food increase in total, right? So low demand holds. And food is normal good. Now, this case. Income and substitution effect in inferior good case. Inferior good case, this is inferior good case. Originally, budget constraint is here and maximize utility is U1. So optimal consumption bundle should be A, right? At this point, your consumption is OF1. Now, price decrease, price of food decrease. So, like this, right? Finally, your choice after changing price is point B, right? So your total effect is this one, F1, F2. Anyway, positive, right? F1, F2, PF decrease, then total effect is positive. Substitution effect plus income effect, anyway, positive, right? Positive, right? This total effects decomposed into two things, substitution effect and income effect. Okay? Then what is substitution effect? So calculate substitution effect is same to earlier one. Now think about budget constraint here. Slope of budget constraint holding relative price of good one or slope of budget constraint same. And find the point touching tangent at earlier utility curve, utility level constant, only price changes. Then you can draw this kind of imaginary budget constraint, isn't it? Right? This budget constraint touches original utility curve at point D. Movement A to D is substitution effect, right? Only what happened? Utility level constant, but relative price PF over PC changes from here to here, holding utility level constant. So movement A to E is substitution effect. Substitution effect is positive F1E. That is same to this one. That is positive. Same to earlier conclusion, earlier graph, figure 4.6. Now think about income effect. Income effect is movement from D to B, right? This one and this one have same slope, same relative price, right? Relative price constant, but your purchasing power increase, utility level increase, right? That is movement to D to B. Then what happens? When you're moving D to B, consumption of food decreases by EF2, F2E, right? When you're moving D to B, this one is negative, right? So this one is negative. Income effect is negative. Moving here to here, D to B, decrease. Demand for food, decrease. That is decrease. Okay? Then what happens in total effect? That when price decrease, substitution effect increase, right? But income effect is now negative, decrease, right? Because that is food is inferior good. That is negative. Okay? That is case of this one. But still, substitution effect plus income effect is positive. Okay? In other words, in this case, substitution effect, impact of substitution effect stronger than negative income effect. So total effect is still positive. Okay? That is case of figure 4.7. Can you understand? What's the difference from figure 4.6? Normal good. So this is positive, but now this one is figure 4.7. Food consumption decrease. Income increase, but demand for that good decrease. But substitution effect, positive substitution effect overwhelms negative income effect. So total effect is positive. What's the meaning of this? Price decrease, then demand for that good increase in spite of negative income effect. In other words, this one decrease, this one increase, total effect increase. So law of demand holds law of demand. What is law of demand? Price increase, demand for good, that good decrease, or price decrease, that demand, total consumption increase, right? That is law of demand, negative relations between price and consumption or demand. So law of demand holds. Law of demand still holds, and at this inferior case. Can you understand? Right? Now, figure 4.A, 깊은 곳. I'd like to explain 깊은 곳. What is 깊은 곳? Same to figure 4.7. Substitution, price decrease. Anyway, substitution effect is positive. Right? But income effect is negative. Same to this one. But this effect, negative income effect, stronger than substitution effect. Influence of income, negative influence effect, income effect overwhelms positive substitution effect. Then what happens? Total demand decrease. Price decrease. Then demand for that good decrease. Consumption of that good decrease. So law of demand violated. That is, we said, 깊은 곳. Okay? So that is 깊은 곳 case. Really exceptional case. Really special case. 깊은 곳. Good. Whose demand curve slopes upward. Slopes upward. Demand curve is slopes upward. In other words, positive relationship between price and consumption. Right? Destroying law of demand. Because the negative income effect is larger than positive substitution effect. Okay? You look at this graph. When food is inferior good and when the income effect is large enough to dominate the positive substitution effect, the demand curve will be upward sloping. Originally this one at point A. Right? And price of good one decrease, then like this. Then what happens? New solution is B. So movement A to B, composed of two facts. When price of good one decrease, right? You draw a new imaginary straight line, holding slope, same to new one, then point D. So movement A to D is a substitution effect, right? Only price changes, holding utility level constant. So EF2 is substitute. Substitution effect is positive. Price decrease, demand for that good increase again. Increase in other words. Now, second part 2, income effect, movement D to B. Income, relative price same, purchasing power increase. Then what happens? Income effect is negative, negative from movement from F2 to F1. So, income effect is negative. And we know from this graph, negative income effect more influence dominates positive substitution effect. So total effect negative. So that is negative. Total effect, this one stronger than this. So negative. So law of demand destroyed, violated. That is 깊은 곳. Okay? So I explained 3 cases. That is really originally this one was positive in normal good. Normal good case. Normal good. Right? Normal good. And normal good case, this is a positive. So law of demand is positive by the wholes. Right? Prices decrease, demand for the good increase, positive, positive, right? And sometimes this is negative, right? But substitution effect stronger than income effect. So low demand still holds. Then we said inferior good, right? Really in special case, this negative income effect dominates positive substitution effect. Then low demand doesn't hold anymore. That is Giffen-Wood case. I explain 3 cases using utility maximization problem.